Section 2-4 is about multiplying rational numbers, and we're going to start off with showing a model of how fractions are multiplied so we can get a picture in our head of what happens to fractions when we're multiplying them. So we're going to start with a situation where we have half of a leftover pizza and we're going to eat 1/3 of it. So we've represented half with the purple shading, and now we want to see how much is 1/3 of that. So we're going to take the half that we have and divide it into thirds. Now remember though, this is 1/3 of a whole pizza, so this line here goes all the way across even though part of the pizza is gone. Now let's shade in 1/3 of that 1/2 that was left. And this area here represents the amount that we've eaten. And remember, this side length is 1/3, and this side length up here is 1/2. So if we're calculating the area, this space that we've eaten, the space that's got purple and green, that area is 1/2 times 1/3. And we can see from the picture that 1/2 times 1/3 is actually 1/6 of an entire pizza. 1, 2, 3, 4, 5, 6, 1/6 of the entire pizza. In this situation, we have two people, and they each have 1.5 pizzas, represented by the purple shading. And we want to show an area model again of the total amount of pizza that we have. So we're going to squish these all together into one picture. Okay, so here's a diagram of all of our pizza. And if we're looking at calculating the area, the space we have in there, we want to multiply our length times our width, and we have a dimension of 2 on this side, and on this side our dimension is 1.5. So if we're going to calculate the area, we're going to have to calculate 2 times 1.5. That represents all of this space in here. And you can see from the picture, if you count it up, 2 times 1.5 equals 3 entire pizzas. We have one pizza, a second pizza, and then these two halves together will give us a third pizza. So 2 times 1.5 is 3, and we've been able to represent that now with a model. So if you notice, when we multiply fractions, we're multiplying the numerator times the numerator, 1 times 1, the denominator times the denominator, and that results in the answer, 1/6. It works the same with our second example. We had 2 times 1.5, and if we write that in fraction form, we have 2/1 times 3/2. 2 times 3 in the numerator, and 1 times 2 in the denominator results in 6/3. Oops, excuse me, 6/2. And that simplifies to 3. Now in your own words, describe the rule or the algorithm for multiplying fractions. And remember, we've been talking about a shortcut that you should take before you multiply fractions. Remember to cancel out. Or in other words, simplify before you multiply. For instance, if we have 2/3 times, 9/16. Remember, we look for common factors anywhere in the numerator and anywhere in the denominator. So I see that 2 will go into 16 and 2. So I'm going to divide by 2, and I'm going to be left with 1. I'm going to divide by 2, and I'll be left with 8 here. I also see that 3 is a common factor between the 3 and the 9, so I'm going to divide by 3 and be left with 1, and divide by 3 and be left with 3. So now I'm looking at 1 times 3 in the numerator and 1 times 8 in the denominator, so the final answer is 3/8. So remember to always look for ways to cancel out, or in other words, simplify before you multiply. Now you try the two problems, 1/2 times 4/6 and 2/3 times 3/4. Okay, now who remembers how to multiply mixed numbers? That's right. You have to turn the any mixed numbers you have, you have to rewrite them as improper fractions first. Okay, so for instance, if you have, let's say 2 times 2 and 1/8, you're going to rewrite the whole number 2 as 2 over 1, and 2/8 as 17/8. And of course, before you multiply, you're going to simplify. So 2 goes into 2 once, and it goes into 8 4 times. So we'll have 14, oops, excuse me. Let me fix that. 17/4. And then you're going to always simplify your answer, so we're going to rewrite that as a mixed number. 4 goes into 17 4 whole times, with one of those fourths still remaining, 4 1/4. Now please do the other two problems on the page, 3 times 4 1/2 and 8 1/4 times 4. Alright, now who remembers the rule for multiplying with decimals? So for instance, if I had whoops, let me put that back. If I had 1.5 times 0.25. Okay, who remembers what we do with that? And remember, you should always be thinking, what's my answer going to look like? I have 1 1/2, and I'm multiplying it by 0.25. I'm taking 0.25 or 1/4 of the 1 1/2. Is my answer going to get bigger or smaller? You should be thinking about that. Okay, so remember, what you're looking for is the number of digits that's to the right of the decimal in the original problem. So I have 3 digits to the right of the decimal. Right now I have 1, 2, 3 digits to the right of the decimal. So in my answer, I should also have 3 digits to the right of the decimal in the answer. Okay, so we've thought about that before we even started doing any work. So then what you do is you simply set up your problem without the decimals, ignore the decimals, and multiply. Whether you're using lattice or traditional multiplication, you're going to multiply, ignore the decimals, but we'll put them back in when we get our final answer. So 5 times 5 is 25, carry the 2, 5 times 1 is 5 plus 2 is 7. We've got our placeholder because we're really multiplying by 20, not just by 2. So 2 times 5 is 10, carry the 1, 2 times 1 is 2, plus 1 is 3. So you add them together, you get 375. Okay, but where does the decimal go in the answer? So remember, we need 3 digits behind the decimal in our answer. 1, 2, 3. So that means we need to place the decimal right there in front of the 3. So the final answer is 0.375. And think to yourself, does that make sense? I'm taking about 1/4 of 1 1/2. Okay, so think about, does that make sense? Now go ahead and write down in your own words how you would describe that rule for multiplying with decimals, and then do problems 1 and 2 on your paper. Thank you.